All right, today we are diving into one of the biggest and honestly, one of the weirdest puzzles in all of physics. It's a cosmic mystery, really, about impossible perfection. So let's start gathering the clues. Our story starts at what I like to think of as a crime scene. But the victim, well, it's not what you'd expect. It's the neutron, a basic building block of you, me, everything. Now, our best theories say it should be misbehaving in a very specific way, but for some reason, it's following the rules perfectly.
And here's the real heart of the mystery. On the left, that's what our best theory of the strong force predicts. It says a neutron should be a little bit lopsided, with a positive charge on one side and negative on the other. But on the right, that's reality. Every single time we look, the neutron is a perfect, neutral, symmetrical sphere. So, what gives?
Yeah, that massive difference between theory and reality, that sets the stage for our whole cosmic detective story. We've got to figure out the secret behind the neutron's absolute baffling perfection. Now, our prime suspect is also, funnily enough, our most trusted informant, Quantum Chromodynamics, or QCD for short. This is basically the rulebook for the most powerful force in nature, the glue that holds atomic nuclei together. And pretty much everywhere else, it works flawlessly. So, any good detective knows you've got to interrogate your prime suspect. So let's dig into the theory itself and look for clues. And when we do, boy, do we find one. We find a smoking gun. Buried deep, deep inside the math of QCD is this one little parameter called the theta term. The best way to think about it is like a single clause in the universe's giant rulebook that specifically allows for this lopsidedness. The rule is right there in black and white. The neutron should be uneven. Okay, so we have a rock-solid theory, and a specific clue inside that theory predicting a lopsided neutron. But what we actually see in the real world tells a completely different story. And the scale of this contradiction, it's just staggering.
So based on that theta term, physicists did the math. They calculated what the neutron's electric dipole moment, which is just the technical term for its lopsidedness, what it should be. And they got a number around 10 to the minus 16. Now that is a tiny, tiny number for sure, but it is definitely not 0.
But here's the kicker. For decades, scientists have run these incredibly precise experiments looking for this lopsidedness, and they have found absolutely nothing. Zilch. All they can tell us is that if it exists at all, it has to be smaller than 10 to the minus 26, a number that is so ridiculously close to 0, it's almost unbelievable.
I mean, it's like your theory predicts a skyscraper, but when you go look, all you find is a single grain of sand. This is a mismatch of 10 orders of magnitude. That's a factor of 10 billion. It's famously called the worst fine-tuning problem in all of physics. It's as if some cosmic dial in the universe is set to 0 with an accuracy of 1 part in 10 billion, and we have no idea why.
A discrepancy this huge, that just can't be an accident. It really suggests one of two things. Either our super trusted theory of QCD is just fundamentally wrong, or something we can't see is actively cleaning up the crime scene, forcing that dial back to 0. This puts us in a really tricky spot. You see, we can't just throw out QCD, it works perfectly for everything else. So physicists had to get really creative and start wondering, what if something else is secretly at play here? So back in the 1970s, two physicists, Roberto Paci and Helen Quinn, came up with this just beautiful solution. They imagined that way back in the early universe, as everything was cooling down, a new invisible field spread out and filled all of space. And the whole point of this field? It acts like a cosmic self-correcting system, automatically, naturally, forcing that pesky theta term down to 0. And, just like every other field in physics, this new field has to have its own particle. And they gave it an awesome name, the axion. The axion is the secret agent that does all the cleanup work. It's the physical particle responsible for the neutron being so perfectly round, tidying up the universe and solving the whole problem with this stunning elegance. But hold on, the story does not end there. Because this hypothetical secret agent, the axion, doesn't just solve one deep mystery. Turns out it might just be the solution to another, even bigger cosmic puzzle.
So when we look out at the universe, all the normal stuff, stars, planets, you, me, that's only about 5% of what's out there. A whopping 27% is made of this mysterious, invisible stuff we call dark matter. We know it's there because we can see its gravity, but we have absolutely no idea what it is.
Well, what do you know? It just so happens that the axion, the particle invented to solve the neutron problem, has all the right properties to be this missing dark matter. It would have been made in huge amounts in the Big Bang, it's super light, has no charge, and barely interacts with anything. It's kind of the perfect suspect for two different crimes at the same time.
This incredible possibility has kicked off a global manhunt. There are these super-sensitive experiments, like ADMX, which are basically giant, super-chilled radios. And they're listening, just listening so carefully for the incredibly faint whisper of an axion turning into a particle of light. But so far, all they've heard is silence.
And the fact that we haven't found the axion yet? Well, it leaves the case wide open. And that forces us to start asking even bigger, more profound questions about the very nature of our reality.
So where does that leave us? We're at this massive fork in the road. Does this whole mystery point towards something called naturalness? This beautiful idea that the universe is fundamentally elegant, and this is a clue to a deeper theory? Or does it hint at something much stranger, the anthropic principle? The idea that we're just winners of a cosmic lottery, living in one of maybe countless universes where the dials just happen to be set perfectly for life to exist.
In the end, the case of the flawless neutron is still very much open, but it leaves us with this one tantalizing question. Is this tiny, perfect detail about a single particle a profound clue, pointing us towards a grand theory of everything? Or is it just one of the luckiest coincidences in the entire cosmos? The hunt for the answer is still on.